Hello, I'm Dr. Leonard Matheson. Welcome to another lesson on work-oriented neurorehabilitation. In this lesson, we're diving into a crucial cognitive ability variable from the ONET framework, perceptual speed. Understanding this variable will significantly enhance your ability to assess, treat, and facilitate a safe return to work for your clients.
These are good quality, no defects. Let's send them through.
Have you ever looked at a crowded scene and quickly spotted what's out of place? Or scanned a document for a tiny typo? That rapid, almost instantaneous ability to compare and contrast visual information is what we're here to talk about today. It's a foundational cognitive skill called perceptual speed, and it's absolutely crucial in countless occupations. Let's start with the official definition from ONET. Perceptual speed is the ability to quickly and accurately compare similarities and differences among sets of letters, numbers, objects, pictures, or patterns. The things to be compared may be presented at the same time or one after the other. This ability also includes comparing a presented object with a remembered object. In simpler terms, it's your brain's rapid-fire comparison engine. It's all about efficiently processing visual information to instantly detect matches, discrepancies, or specific features. It's not about deep thought or complex problem solving. It's about swift, precise visual discrimination. When we have a client who has significant shortfalls in perceptual speed compared with the demands they face on the job, their cognitive rehabilitation program is a rigorous reiteration of just right challenges to help them bridge the gap. I like to refer to this as sequential cognitive scaffolding, or SCS. The term sequential highlights the step-by-step nature of the perceptual speed cognitive process and the rehabilitation approach. Cognitive scaffolding refers to the process of providing targeted support to help an individual remediate an ability, and then gradually removing that support as they become proficient. Together, the term effectively describes the iterative process of identifying and addressing impairments at each specific stage of the perceptual speed process before moving to the next. So what are the basic components of perceptual speed that we need to address? There are four altogether: sensory input and initial processing, feature extraction and pattern recognition, comparison and discrimination, decision and response initiation. Now let's take a look at how the perceptual speed cognitive process evolves. Let me take a moment to elaborate on the cognitive processes underlying perceptual speed by examining the interconnected stages of this cognitive process. We begin with sensory input and initial processing. Light hits the retina and the visual information is transmitted to the brain. This initial stage involves the rapid detection of basic features like lines, shapes, colors, and motion. Next, the brain uses that information in a process called feature extraction and pattern recognition. The brain then starts to extract more complex features. For example, it might identify a specific letter, a familiar face, or a particular symbol. This involves comparing the incoming visual data with stored templates and patterns in long-term memory. Once the raw patterns of visual data become apparent, the comparison and discrimination process unfolds. This is where the speed aspect becomes critical. The brain rapidly compares the extracted features of different stimuli to determine if they are the same or different. It involves filtering out irrelevant information and focusing on the crucial details that allow for quick categorization or differentiation. Finally, we reach the brain's decision and response initiation stage of processing, where a decision is made to initiate or withhold a response, which can be a motor action or a mental acknowledgement. Essentially, perceptual speed is a highly efficient and largely automatic process that allows us to navigate our visually rich environment effectively. It serves as a fundamental building block for many other complex cognitive functions. Let me tell you about one of the most remarkable clients I've ever worked with. Let's call her Maria. Imagine a 48-year-old single mom raising a teenager with special needs. who had climbed the ladder at the FAA to one of the most demanding jobs on the planet, an air traffic controller at a major international airport.
American 235, descend and maintain flight level 240.
Think about the cognitive skills that her job demands, especially perceptual speed. She was responsible for dozens of aircraft, hundreds of lives, and processing complex visual data on a screen in very few seconds. Quick, accurate, and under immense pressure. She did this flawlessly before she got hurt, and was very well respected among the controllers with whom she worked. Then one sunny afternoon, a bicycle accident changed everything. A traumatic brain injury. When Maria came to our neurorehabilitation program, her goal was clear: get me back to my tower. We worked tirelessly, focusing on restoring the high-level cognitive skills her job required, and she made incredible progress, gradually resolving problems with almost all of her cognitive processing abilities. Along with all of her other abilities, we tracked her improvement in perceptual speed using the ONET behaviorally anchored rating method. When she was ready to be discharged, she had achieved a bar score of 3.5. Now, for many professions, a 3.5 is a fantastic score. It demonstrates a solid ability to quickly and accurately compare and process visual information. We were thrilled. But the ONET perceptual speed bar score required for air traffic controllers wasn't 3.5. It was 4.38. In most jobs, that difference might not be critical, but when you're managing planes in the sky, that 0.88 point difference is the space where mistakes can happen. It's the margin between a safe landing and a catastrophe. This was the hardest conversation. We had the data, the objective measure. Maria was a high achiever, but the data showed that even at her best, post-injury, she couldn't meet the razor-thin margin of safety her job demanded. And here is what makes her story so powerful. She wasn't defeated. She was redirected. Faced with this data, Maria made a courageous choice. She decided not to return to the tower. Instead, she used her long-term disability support to go back to school and earn a degree in electrical engineering. She channeled that same powerful intellect, that same ability to solve complex problems into a new field. Today, she has been working as a successful engineer in Silicon Valley for the past 12 years. Her story is the perfect illustration of why ONET data is so vital. It's not about limiting our clients, it's about empowering them with realism. It allowed us to have an honest, client-centered conversation about her capabilities and to pivot from a goal of restoration to a new incredible goal of reinvention. She didn't fail to return to her old job. She succeeded in creating a new, fulfilling life. And that, right there, is the art and science of what we do. Thank you for your time and attention. I hope you found this useful. We'll continue to explore ways to enhance our abilities to support our clients, particularly those in high-stakes or potentially hazardous jobs, in safely and reliably returning to work. If you have comments or questions, I would be delighted to hear from you. I can be reached at this email address,